Hello, everybody. It's been a while. Um, I just took some time off to reflect on what to do next, apart from all those book reading videos. And yeah, I just was reminded about why I even started this channel. It was just for me to keep myself accountable for learning new things and um, yeah, and just have some fun. And I don't want to make it super serious and also um, pretty much get to the point where I have to force myself to make these videos. I want to make these videos and show everyone what I'm doing and what I'm learning for just the fun of it. Um, so yeah, just saying hi again, everybody. And hopefully my audio has gotten better. I've been trying my best to adjust it. I have it in OBS like 167% over whatever the default is. So anyway, so let's learn AI. How about it? Let's just learn about LLMs. Let's just see what this is all about. So I'm going to today just see if I can build llama.cpp and then just see if I can run like a local model and then install like Open Web UI, which is like a GUI for just chatting and interacting with the LLM. So I'm going to first do that with a smaller model and also build llama CPP with GPU support. So this computer actually has a GPU now. So if I do NV top, oops, don't have it. CABD install NV top. So if I look at NV top, I have a RTX 84000, which is a 16 gig GPU. I think I think that should be like enough for what we want to do here. So we can get some like interesting large language models like installed, and we can like write some simple apps to see how we could take advantage of large language models. Um, I don't believe that we should use large language models like the way we do with, for example, ChatGPT or Anthropic Cloud, um, because those are like really big models, right? And it's really hard to compete with them if you're just interacting them with like chatting. But you can really use small language models for things such as like for example, if you're like privacy focused and you don't want your data leaking out into the cloud by interacting with these models with like for example OpenAI, you don't want them to have like any of your financial documents or anything like that. You can actually run a local large language model or a small language model and actually feed that data in and get some interesting insights. Or you can also treat them as like agents where they actually do jobs for you, or do document retrieval with like retrieval augmented generation, what we call RAG. You can do a lot of interesting things that you would normally be kind of scared to do on the cloud. So let's just start exploring things maybe like that. But first things first, let's get Llama CPP built and installed. So I'll do just that. So first, I'll just go to the Llama CPP repo. Llama CPP GitHub. So it's pretty basic. It's just vanilla C++. So we should be able to get started relatively easily. So yeah, we'll just clone this repo. It's already optimized for CPU and GPU, especially since we have NVIDIA. Should be fine. So I'll just clone it anywhere. I'm going to make a directory called repo, and then I'm going to cd into repo, and then I'll just do git clone to llama cpp. And shouldn't take too long. Okay. Okay, so then, oh, maybe this is too small, sorry. You know what, let's just do this. Yeah, let's do that. So, build instructions are in the documents somewhere here. I think it's in docs, right? So we'll have build. Once that's done cloning, we'll have build. Okay. So there's like a way to build for CPU, and then there's also a way to build for, I think, CUDA, but that should be pretty easy. I think it's just tacking on a compiler flag, which is dash DGGML right here, like CUDA on. So this is like pretty easy, right, to do. So yeah, let's just try to see what we can do with this. So we're gonna use CMake. We're gonna create the build configuration inside the build directory, and then we're gonna build with the ggml CUDA flag on to enable CUDA. Just make sure that you have CUDA installed. You can just leave this off if you don't have NVIDIA graphics card. It'll just be on CPU only, and I'll show you how fast that would be on computers. And then after that, you'll just build the release version of llama.cpp. And I think there's like another step to just install everything in. So I think it just copies everything over somewhere here. Where is it? You know what? Probably not in here. I know there's a blog article that does this, llama.cpp run anywhere. Right here, this guide is really good. So this is where I first learned it. So building llama, he has a specific command that he uses. We'll probably kind of build our own command, but yeah, it's similar to this. He just has like an install prefix, which you should have, where you want to install llama cpp to after you've done building it. And the command that I'm trying to look for is actually this one, the cmake install build config release, after we've done the regular build. So yeah, let's actually write that command. So now that we've cloned the repo, right, so it'll just be as simple as navigating to llama cpp, and then if we just looked at what we have here, we just have a regular cmake project. We already see the cmake here. So we just do cmake -b build, okay, -ggml CUDA on, right? But he also has like a bunch of other things too. One of them is the prefix, right? So if we were to go back to our browser and then look at the prefix, it'll be dcmake install prefix right here. So that's where we're gonna dump our built files into our file system. And then there's also things like don't build tests, build out examples, and then build a server. I guess this is server. So I kind of want to rip all of this off anyway, so let's just try to copy and paste everything into our terminal. So we do that. So cmake build type release, cmake install prefix, let's keep it in home bin llama.cpp. So we'll need to make that directory, and then the build tests off, right? So -d llama build tests off, -d llama build examples on, and then build server on, because we'll need that for inferencing. So we do that, it'll start to just build the, I guess the build definitions or whatever. But we also need to make sure that we create the llama cpp directory so that when we install, it'll go into all those all those files will go into that directory. So we'll make dir p. So then if we were to ls home /bin, we'll see that every single file in there is going to be dropped into llama.cpp whenever we're done. Oops. So we do that. So it's empty right now, but we'll start to see stuff after we build. So we're still in this directory. Now we have a new directory called build, right? So if we ls current directory build, right, we'll see that all the cmake stuff is in here. So let's actually build it. So going back to the guide here, we'll have something called cmake build config release. So that's all there is to it. I think it's the same thing even with CPU build and CUDA build. It's the same command right here, you see. So just copy paste, and then I think we can specify make flags for number of processors to build with concurrently. So he does that with -j. I will do the same. I will do -j and proc, and then it should start building. So yeah, so I'm building with CUDA, so you're gonna get all these warnings. And after that, we're going to just do the install step where it just copies all the built files, and then it'll just be able to run normally. So yeah, let's see here. Is this an error? Parameter packs not expanded with blah. That makes me nervous. Let's see what happens. So the compile failed, so I had to do a sudo apt dist upgrade, and then I got a lot of this CUDA stuff that's being upgraded right now. So I think that's what was going on. So I'm just in the process of upgrading all my packages. It's actually a lot, didn't realize. So it feels like it might be done soon. Let's see. Or not. Okay, so it says now I have NVIDIA driver 550. Maybe? Do I? No GPU to monitor. Oh, that's not good. Let's reboot. Okay, after rebooting, it does look like it works now. So NVIDIA SMI. So driver version 550, CUDA version 12.4. Okay, I feel like I should at least redo that CMake build thing. So if I do RMF build, let's see here. Where was it? Let's just redo it. Let's see what happens. Oh, it says CUDA toolkit found version 11.5. I wonder if that's like because it's an old version. Llama.cpp run anywhere. Or actually, let's look at the official documentation, and let's see if the CUDA version actually matters. If that is the case, then uh-oh. Looks like it doesn't matter. Maybe? Yeah, it doesn't. I don't know. Let's see. Okay, so we have that. Let's build. Okay. Bizarre. Okay, so now let's do this. Let's just download a later version of NVIDIA toolkit. CUDA toolkit. Maybe we can get a later one, right? So download. How do we do this? Oh gosh. Linux. Manage settings. I don't know. Decline all. Something like that. Let's see. x86-64. Ubuntu. I'm 2204, which is always a mistake, but I have some plans. As to I have plans later, and that's the reason why I'm on 2204. It's ancient, so I know this is gonna fail, so forget it. I am going to just do this, and then I'm going to install everything here. Okay, I'll do all these steps just to get toolkit. So hopefully I didn't host my system by just doing all this driver manipulation. Okay. All right. Well, last step. Install CUDA Toolkit 12.8. Let's see what happens. Wait, we're already at the newest version. The following package will automatically install, no longer required. Sudo apt auto remove. Okay. Should we also install the driver? Maybe. Okay, looks like we're gonna get the 570 driver. Not sure if that makes a difference. I don't know how old 550 to 570 is. Okay, it's doing stuff with the kernel now. Okay, so it says update init ramfs. I think that's a good sign. At least the drivers got installed. So I'm guessing I need to restart if I did NVIDIA SMI. Yeah, so it failed, so let's just do one more time to reboot. Okay. Let's hope that works. Oh, that's not good. Okay. NVIDIA SMI. Okay, we have 570 NVCC version. I guess that's how NVCC version. Yeah, it's still old. What do I do? Actually, you know what? Let's do this. Let's see. LS user local. Okay, CUDA 12. CUDA 12 8 12 CUDA-12. Okay, so if we did cat etc environment, what do we have? Okay, so we did cat etc cat, or let's do tail bash rc. I wonder if we can just like override CUDA. So we did lsla, it's ls usr local. Sorry, LA. So this is a symlink to CUDA 12. So I wonder if we can like manually set the compiler version. I vaguely remember this. So let's see. NVCC set compiler. Set host compiler. Set default host compiler. It was some sort of export. Not this. Default host compiler. Not this. Let's do this. NVCC export CUDA USR local CUDA. Let's do that. So CUDA home path. So export CUDA home. Okay, I think it's this one. Okay, so let's do that. Let's do vim bash rc exports CUDA home to be USR local with a CUDA 12. Okay, source bash rc. If I did MVCC version, I still get this. conda prefix. How about this? Environment setup. There we go. The path variable needs to include USR local 12.8. Okay. Sure, let's do that. Let's just stick this in and hope for the best. This is copy and paste because I don't know. Okay, so if I did this, okay, easy enough. I should probably read directions. I might have. Okay, that's it, right? It looks fine. So let's do nvcc -- version. Oh, look. Okay, that's good. So if we did rmrf build again and cmake this. Okay, so we found CUDA 12.8. Okay, cool. Okay. This is still weird, but sure. CUDA host compilers GNU. Okay, well, let's see what happens. CMake. Oh, geez. What? Unrecognized compressed mode size. NVCC warning. Blah architecture. Okay, you know what? I'll get that working later. I am just gonna build this normally. So let's just build a CPU. Okay? And let's see if we can just build it normally. Whatever. Okay, so this will work for sure. I'm pretty sure. We have nothing special that's going on in this mode. See, nice and easy so far. Okay, so see, that worked nicely, right? So then we just need to now like make install. So llama.cpp on anywhere. He has that one command. So building the llama. So it's gonna be right there. CMake install build config release. So we just do that, and it's gonna copy everything to bin llama.cpp. Okay, so good. We do have stuff there. So then if we were to go and look at our bin llama.cpp directory, we do have stuff. So we have a bunch of the llama.cpp binaries. So that's good. But I did come across something interesting during when this thing was compiling. I forgot to export my LD library path. So let's actually just do that too, and then see if we can compile with CUDA again. So, but it's okay. We already built the CPU version. We'll just leave it as is. We won't install it if it fails, so it's harmless. Okay, so I'm gonna rmrf rimraf build. Then I'm going to do cmake with CUDA. Wait. Before I do that, vim --rc. I'm also going to export LD library path. I don't know why it's like this. Let's just remove sketch stuff. Like that. Okay. And then we're going to source. And then let's try to build again with CUDA. So, okay. Well, well, I see check for working CUDA compiler, user bin nvcc skip. CUDA compiler identification is NVIDIA 11.5. Why is that? Let's read the directions. Why? Why does it identify that? we could always do this, right? We could always like relink. Should we? 12.8. Let's do it. 12.8. We have 12.8. So let's just manually do it. Let's break our system, everybody. Boom. Okay. Rimraf build. Do it again. What does it say now? Hey, look. Compiler. Okay. F it. I don't care. We have llama.cpp. Watch, it doesn't work again. So it's just, even if I did this, it's not gonna work, right? Oops. Where is it? Let's see if I did this one. I'll probably have errors. Yeah, so forget it. Let's just stick with CPU inferencing. Told you, I'm learning. Okay, so we need to get a model, right? Necessary cookies. So let's get a free model. Let's go to Hugging Face. Oops, huggingface.co. Huggingface.co. So let's just get like a free model. I don't know. Let's do something that everybody knows. Let's do the DeepSeek one, right? But I think this computer definitely can't handle that big of a DeepSeek. Actually, I want to do something more traditional. Is there like a V3, but there's only like a big one too. What other ones do we have that's like easy to run? Let's do Mistral. Mistral 7B instruct. Why don't we do that one? Yeah. Oh, you need to agree to share your contact information. How about Qwen 2.5? 7B instruct vision. Is that vision? I don't know. Let's do 7B. This one's nice and free. Okay, so when you get a model from Hugging Face, it's going to be in the safe tensors format. So we're going to have to like use some skills to kind of convert that to what llama.cpp wants. So we'll just get clone this somewhere. So I just make their models in my home directory. I'll do cd models, and I'll just make a clone. This one. Okay, so it should be pretty fast. Okie dokie, that finished. So let's see. We have Qwen 2.5 B7 2.57B instruct. So we have all these safe tensors files here. So each one's like 3.95 gigabytes. We want to convert that into GGUF, which is going to be the format that llama.cpp understands. So we got to go back to our llama.cpp repo, right? There's a specific script that we want to run right here. It's going to be convert hf to gguf.py, and that's just basically going to convert a specified directory with safe tensors into gguf. So if I and we can't just like straight up like how should I say this? We can't just straight up run this. We had to like be in a virtual environment. Hey, now that I think about it, I didn't pip install requirements for a virtual environment. Maybe that's the reason why I keep messing up on the CUDA thing, but maybe for another video. Anyway, so let's create our Python virtual environment under here. So I have Python 3 version. Crap. Okay, so let me install, I guess, I like to install 3.12.3 because that's like what mostly everything works on. So let's do this. Let's do pyenv. Let's get pyenv, and then let's install it. So pyenv will let us actually control the Python version that we have. So I'm just going to use the curl script, and then just do that, and that will install pyenv. And then we just need to add this into our bash rc at the end so that it starts up the pyenv environment. Okay, let's just make sure it's all there. Okay, good. Okay, so now I think the command to just install Python in version is what? No, not here. Restart your shell, which I already did. Install Python build dependencies before attempting to install a new Python version. Okay, sure. So Linux. Okay, so we need all this stuff here. So let's just copy that, paste, hope for the best. Okay, it's finishing up. Okay, finished. Now, for real, let's see if we can install a Python version. How do we do that? Okay, pyinf install and then the version we want, and then we can make it global, right? Let's see, how do we make it global? Right there, pyinf global. So we can technically just do this and just change the numbers around. 312.3, 312.3, let's just do that. Boom. Okay. So that's going to download Python 3.12 source. It's going to build from source, and then it's going to set Python 3.12.3 as the global version. Okay, that looked like it works. So we do Python 3-version. Where we get? Okay, cool. So now we could actually create some virtual environment, right? So we can do Python 3-m venv.venv. Okay, so we'll create a virtual environment in the .venv folder. Then we'll do source.venv bin activate to activate the virtual environment, which we have right here now with .venv. Then we could just do in this directory we have requirements.txt, so we could just do pip install -r requirements.txt, and that should get us there. Okay, that's done installing. So we're in a virtual environment. Let's just run the convert was it hf to gguf.py, but let's look at the help text, right, to see how we use it. So it's just basically the script plus the out file you want, the gguf file you want output. I don't really care about all of this stuff, but we need to provide the directory to the model. So it's just going to be Python convert hf to gguf.py, and then the out file we want, let's just call it so we'll put in models Qwen 2.5 7b.gguf. Okay, maybe you should say instruct too, so that we know this is instruction fine-tuned model. And then we provide the directory, in this case what was it called again? Qwen 2.5. I don't know where is it split. Pane down. Oops. Okay, cool. I had the gist. 7b instruct, and just leave that directory there, and then it should start to do that conversion. So yeah, it's a 15.2 gig model, but it's going fairly quick. So after we converted the 6 tensors to the gguf, I'll show you how it looks like converted. It's going pretty fast too. Okay, so we do ls la home models. We'll see that we have the gguf right here. It's like straight up 15.2 gig. So that's like not quantized, that's using like floating point 16. So we want to kind of quantize that model to reduce the size so that we don't run into weird memory issues. I'm going to quantize it since it's only 7 billion parameters. I'm going to quantize it to 8 bits. So Q80 is what we want to be. And that's actually provided in the llama.cpp binary files that we've built. So we went into here, we can see that there's a specific program called llama quantize. So if we go to llama quantize, we can run that, and then we'll see what we have available for us if we get the help text. Oops. Oh, wow. Static. Let's rebuild this thing with static libraries. It's doing dynamic libraries. So I'm too lazy. I really want to build with static libraries. So then let's find a command to do that. Let's go llama.cpp again. And then if we were to go to build, it should be fast. It should be fast. So build static build. Okay, build shared libs off. Let's do that. So we're going to, again, build this for CPU, and then we're going to do the install, and then, yeah. Okay, so going back to code repo here, we can then do cmake -b. Okay, so we'll do this, but then we're going to replace this with, oops, build shared libs off. We're also going to rimwrap build and then run this command. Okay, and then we're going to cmake build config release. Okay, so that should pretty much rebuild the thing, but this time statically link all the libraries because I don't want to deal with dynamically linked libraries. Just want to keep things simple. I mean, it's already been like almost 45 minutes here in real time, so I haven't even like did stuff yet. So anyway, ouch. Okay, all right, so again, we'll just install it, and then let's go back to our bin directory. So cd whatever, this directory, home bin llama.cpp bin. Now let's run llama quantize with the help text, and we should have stuff here. Okay, cool. So basically run the program, and then it's going to be where we're at, the output file you want. So no, this is the input file, and then this is going to be the output file you want in terms of what you want quantized, and then the quantized version, like how much you want to quantize. So this will be like Q80. Here are all the options here. Notice that if you go less and less, you just basically because you get like your model becomes dumber, right? So let's just keep it Q80. So it's just gonna be llama quantize, and it's gonna be the original file in this case .gguf, and then we're just gonna dump it again into the same directory, but this time we're gonna say Q80.gguf, and then we want to quantize to Q80, and we're gonna do this with 40 threads because I have a 40 thread CPU, and let's see what happens. It should be super fast because 40 threads, right? I should use all my threads. There we go. So okay, so now that's done. Great. So let's actually run the model, right? So again, we have something called llama server. Yeah, right here. That allows us to actually run it and then be accessible from web UI. So I'm gonna do llama server, and I'm gonna specify host to be 0.0.0.0, port maybe 8888, and then the model file is going to be home models Qwen blah blah blah. It's gonna be what, Q8, yeah, whatever .guf. And then I'm gonna do temperature is going to be, let's just keep it at 0.6, and then min p 0.1, and then I think that's it. So if we were to just run it like this, it should load everything, and it goes quite fast. So it's all loaded. Now let's navigate to let's just do localhost 8888, and we have a chat interface to just test our model. I like to show the tokens per second, and then if I were to just type hello, how are you? And it's pretty fast. Not bad for CPU inferencing, right? 24.7 tokens per second. So yeah, okay, you're just a computer program, don't have feelings. Okay, sure. How about this? Write me a C program to perform a curl request using a curl post request. Be creative. Okay, let's do it. Okay. So it uses libcurl, and I'm not going to even check the program, but yeah, you see it's going. Processing 23.2 tokens per second, which I think is okay for this computer here. So it's trying to use, I guess, as many threads as possible, but my RAM is being used 16.2 gigs. This model size should be only about 7 gigs, 7 to 8 gigs, since it's 1 byte per parameter. I really don't care about this. Basically, it generates 721 tokens, 22.1 tokens per second, and it has stuff here. I don't know if it works or not. Forget it. That's not the point. The point is we got up and running with llama.cpp really quick. I need to fix the CUDA thing. No idea why, but then again, I hate setting up graphics cards. It's always like that. It's never smooth for me because it's a skill issue, I think. So let's just code, right? So maybe next time. Anyway, this video ran too long. At least we have something set up. Actually, you know what? Let's just write a quick script. So let's do this. Let's make an alias, actually. So let's just say start Qwen, right? Let's just call something called start Qwen. So I do vim bash rc alias start Qwen. Just do that. And let's edit this a little bit. To just say home bin llama.cpp bin llama server. And then if I were to source, bash rc again, I should be able to just do start Qwen, and I'm off to the races. Okay, cool. One more thing I realized, source. Let's just create a new virtual environment for this. We need to install, is it source? Is it deactivate? I think it's just deactivate. Anyway, let's deactivate this virtual environment and then go back to our home directory and create a virtual environment in our home directory, and then install OpenWebUI, and then let's interact with Qwen that way. So I'm just going to do Python 3 whatever, create the virtual environment, and I'm going to source the virtual environment, and I'm going to do pip install OpenWebUI. So that's going to install OpenWebUI, which is going to be a nice fancy interface to interact with our LLM. So it's going to be a while. As you can see, it's a pretty big program. I'm hoping it's worth it. Jeez. And they said that Node.js had an issue. Okay, that looks like it works. So let's do this. Let's start up OpenWebUI. No, first let's start up Qwen. So let's have Qwen start up on this port, and then let's open another tab, and then let's do source vnv bin activate, and then open WebUI serve, and then let's just open it up for all our network interfaces. And then we should be able to go to the UI. Oh my gosh, more? What is all this? It's the Matrix. It looks like it's trying to go as fast as possible though. Anyway, I think it's done. So let's go to our local host. And I think this is on 8080. So here we go, get started. I think it just makes us register. Average dev, average. Okay. At averagedev.com. Yeah. Sure. I don't know. Okay, so let's set it up real quick. We don't have anything. So let's just go settings, admin settings, connections. Let's add one. I don't want OpenAI. Let's replace that with our stuff. So it's going to be localhost 8088. get rid of this because it's not HTTPS. No API key. That's what documentation says. So going to go back, go to a new chat. So now we have Qwen, and this is like ugly. I don't like this name. So let's go back to admin settings, models. Let's change that to Qwen. Qwen 2.5 7B. Okay, I'm happy with that. Check usage. I want to know the tokens. Okay, so let's do it again. So hello there. Cool, that works. Okay, let's just give it a number. 345. No, let's just give it a BS number times that. Let's see if it can do it. So it's gonna come up with this. Is that correct? Let's see. So let's throw that into Google, and it's 429715. How about this one? Oh, it's wrong. But if we do it like this, please use code. Okay. Uh-oh. How can it actually run? What do we get if we run it? There we go. So that's the result. So can we get the model to do that? Okay, so let's do this. Please, let's do this. Please use code and run it to get the result. So let's ask it again. Oh wow, it's not doing it. Okay, I think there's like more configuration involved, but at least we could run the code, right? So we can just do that and get the answer. So that's the answer. Yeah, LLMs are dumb. They don't really know how to count. So that's the reason why they just like make shit up. So yeah. Can we do this? Execute code for now. I don't know. Whatever. We'll explore more later. But at least we have a LLM. Let's try to make this thing smarter down the line with some tools and code that will develop. And right now it's unimpressive. In fact, it already messed up. But let's see what we can do with it. Yeah, let's do it. Next time.